All right, so in this problem, we've got problem 6.3. This is another similar one to the 6.1 that we just did. So in this, we've got a power supply of 6 volts, a resistor of 2 kilo ohms, an inductor in here, another resistor at 4 kilo ohms, a capacitor, a power supply facing up at 12 volts. And then here we're going to start out with the switch pushed, and then at T0 we're going to open that switch. So it's going to be a short circuit, an open circuit there. So right now it's a short circuit. So if we're going to just look at what's happening at a long period of time up to 0, we have some voltage coming through here, and it's going to come around here because that's ground. We also have some voltage coming here. It's going to come here because it comes around ground. So this is a point where these two current lines are going to add together. And so that's an easy way of doing this. When we switch the switch, now one of these is going to overdrive into the other one. And we're going to have cool stuff happen immediately at 0 and then also over a long period of time. So let's start this out. At t, let's draw t equals 0 minus. And for this one, let's look all the way up into, for infinity, in negative infinity to 0, what's going to happen? Well, at infinity, these inductors become short circuits and open capacitors become open circuits. So let's draw this out. We've got a positive, a minus. We've got a resistor. We've got a short where those are. We've got a resistor. We've got an open and a voltage supply. Almost forgot that. And then we've also got another piece like that. So that's what it should look like over a long period of time. And let's just do our 2 and 4 and 6 and 12. All right. So let's look at each part. Our voltage drop over our voltage drop over the capacitor at 0 is going to be what? Well, we have ground here, and we have ground all the way up here. And there's no current flowing through here, so this is going to have to be all of our voltage drop, because again, that's going to have to come from 12 to 0. Okay, so 12 to 0, because this is one giant 0, so we agree that it's 0 here, all the way up and over here. Okay, and then it's also 0 here, because there's nowhere for current to flow, so this also has to be included in that 0. And that's why it's 12 minus 0 equals 12. So if this is our direction of current flowing out like this, we have our capacitor has to equal the opposite of this. So 12 minus 12 equals the capacitor. So VC of 0 equals minus 12 volts. That's 0 minus, right? Or is it just 0? It's just 0, because that is what's happening at 0. So that is our there, and then our IL of 0 is going to equal. So our IL is going to be this one right here. Now this does have current flowing out, so this has got to go out. So this current has to get out of here in order to get into this giant 0. So we're going to have what? V equals IR, so that's going to be what? 6, which is our source, over 2 kilo ohms is going to equal to 3 milliamps of current. That's going to be our IC of 0 right there. So we do have some current flowing through there into this point, and it's all going to add up to 0 there. Okay, so that's our first bit. Now we're going to do our t equals 0. Our t equals 0, this is exactly when this switch is opened. So what's going to happen when the switch is opened? Well, when this is open, this whole thing is just going to disappear on this side. So we're going to get a positive minus 6. We're going to have a resistor. And now the most interesting part. So this is already charged up. So that means this has, let's draw a different color just so it doesn't distract. This has really nice magnetic field lines built up in it. Okay, so what's going to happen is when we open this, these field lines are going to be creating current through this. So this is actually from chapter 1, a current source of 3 milliamps. And we know this is the current source because that's how much current was totally saved up. And we have this from the 0 point. So this is 3 milliamps of current going to get dumped in here. And we have a resistor here. And then we have our capacitor becomes a power supply, which is going the opposite direction of our second power supply. So this is 12, and this is 4 here, and then this is 2. And then we already know from this one that our capacitor was totally fully charged with 12 volts. So this is going to be like a positive 12 down here, and this is going to be your 0 point from that. So it's like pushing this to this. So if we want to do, we have one loop here, KVL at this loop. I'm going to get -6 plus 2 kiloohms times 3 milliamps. And that's the first bit. Voltage, resistance times current, V equals IR, plus VC of 0. Okay, good. Plus, all right, so now we've got this one. So we have a current here, so this has to be the current going through. So this is going to be 3 milliamps times 4 ohms, because IR, V equals IR. And then this is going to be -12 for this one, plus 12 for that one, equals 0. So 6 I R, because we only have one I, so it has to be anytime we see I, 3. So then over here we've got I R, then we've got this one, -12 plus 12. Okay? The voltage across our capacitor is this one, so we can just kind of cross that out. I already just solved it in there. So our VL of 0, if we add that all up, equals -12. Nice and easy. So finally, for the last bit, we have T equals infinity. And at infinity, we have a power supply, we've got a resistor, we've got a short, because that inductor is going to be filled, we've got a resistor, we've got an open circuit, we've got a power supply, and then we are going to bring this back down there. Because again, after infinity, this inductor is going to be totally filled with current. It's going to be storing all that, so it's just a short. And at infinity, this is just an open capacitor. So here we've got our V capacitor at infinity. So that's the voltage across the capacitor, is going to be the one of these voltages minus the other voltage. So that's going to be 6 minus 12 volts, and this is going to be equal to -6 volts. So there's -6 going, and that makes sense because look, if this is our positive and this is our negative, it has to resist this. So 6 positive plus 6 equals the 12. So that's how it balances out. And then our IL of infinity, we've already discussed. IL of infinity, nothing. Boom, done. So that one's another kind of fun one to do too. I do enjoy these a lot. Let me know if you guys have questions.